Hello and welcome to our lecture on Module 4 ACL Concepts of Enterprise Networking, Security, and Automation. My name is Kelly Caudle and I am the lead instructor at the Instructor Training Center at Stanley Community College. I'm going to go ahead and give you your standard disclaimer here that this is a just good enough video, so there may be missteps, there may be ahs, phone may ring, I may have to pause if someone comes to my office. I do my videos based upon the idea that if you're in my classroom, my lectures wouldn't be perfect, so my videos are not going to be perfect. I strongly suggest if you're not already in a Cisco Networking Academy and you're watching this video, find one locally and get into the academy, learn your IT skills, and have a great career in information technology. This particular chapter is on ACL concepts, or access control list concepts. I want to pull over a quick notepad item I've come up with to give you some basics of access control lists. ACLs are a series of permit and deny statements, and those statements are typically called ACEs, or access control entries. So those are the individual statements in an ACL. So ACEs are the individual permit and deny statements. But those series of permit and deny statements are applied logically in a sequential order, and that's going to make sense, a little more sense when we start actually applying them, because they're applied sequentially top down, which means if you put an ACE in that says permit all traffic, and then underneath that you put another ACE in the same access list that says deny some host. Well, the ACE above the secondary ACE that was denying a single host, the one that permitted all traffic, would act on the packet first, and it would be the one that would send the packet out the outgoing egress interface. So that's very important when you start creating ACLs, that you think about the logic behind your ACL. They all end in an implicit deny. So in other words, at the end, if you don't put anything, so if I make an ACL that just says deny host X, so host 192.168.12.10, if I do that, the next implicit item in that ACL is a deny all or deny any. And so if you don't allow at least one permit statement inside of an ACL, you're going to end up blocking all traffic. Very important concept. And then we also will see that there's, you can place one ACL per protocol, per port, per direction. And we'll talk a little bit more of that as we go through this chapter. And I'll bring this back over when we actually discuss standard and extended ACLs also. So in this chapter, we're going to look at what ACLs are. We're going to look at wildcard mask as they're used in ACLs. A little bit different. Well, it's similar, but very different than what we see in OSPF, because you have an OSPF wildcard mask is an inverse of what would have been the network mask for a network. In an access control list, the wildcard mask is actually used to determine what portion will be matched in an ACE. So we'll get to that when we get to that part of this chapter. Guidelines for ACL creation, and then the different types of ACLs that are available inside the Cisco IOS. And by the way, we're only looking at standard and extended ACLs inside the CCNA. There are other ACLs, and there are many different uses for ACLs. This particular chapter talks about an ACL can be used to limit network traffic. In other words, we can prohibit certain access to certain sites, to different types of traffic, do traffic flow and control, basic packet filtering security. We can screen host. It's actually, I call access control list kind of like a multi-tool for the Cisco IOS. So they are used for security, but they're also used for things like determining what can be natted in a NAT statement. So using a NAT ACL to determine what will be natted and what won't be natted. They're used for distribute list to determine what routing protocols will send in and out in their routing table updates or accept in their routing table updates from neighbors. So ACLs have a bunch of uses other than just security. So that's why it's very important to learn how to do this, these particular ACLs. In this chapter, we're looking at them primarily as a packet filtering security device, which means we're going to filter based upon layer 3 and layer 4 information, which, as we all know, layer 3 is the network layer, which deals with IP addresses. It deals with logical addressing, such as IP addressing. And the transport layer, which deals with TCP, UDP, and types, source ports, destination ports. So we're going to be able to filter using those two items as the primary filtering mechanisms for our Cisco routers. We have standard ACLs, and we'll talk more about those in a little bit, but those filter based on source only. And we have extended ACLs that filter based upon source, destination, source port, destination port, and even the protocol type. Now, ACLs, I mentioned there can be one ACL per protocol, per port, per direction. It is important that you realize that all ACLs, when you're looking at their direction, are referring to a person sitting in the router. So if there was an interface on the left side of R1 here, a gig 00 for instance, inbound would be any traffic coming into R1 in that direction. On gig 00 on the left here, the outbound would be going out away from the person in the router. So this particular diagram shows an inbound ACL going towards gig 00 on the left side, and I know they don't have gig 00 here, but just imagine it's there. And on the right side, there'd be a gig 01. Well, inbound would be, on the right side would be any traffic coming into gig 01 from the right. So inbound and outbound is always based upon you're sitting in the center of the router. And then you look at the interfaces from that point to determine what is an inbound or an outbound direction. Now, when we're doing our actual access control list, the packet comes in, it is applied and looked at, or looks at the ACL, and each individual access control entry in the ACL will be compared against the inbound traffic. The very first access control entry in the ACL that matches is what will be used for that particular packet. So it would be a deny or permit. That's why when I mentioned earlier, logically, it's very important that you keep up with how your ACLs are configured. If no access control entry matches a packet, it's dropped, all right? Because there's an implicit deny, and that's what I mentioned earlier, an implicit deny. So now wildcard mask we've talked about in OSPF a little bit, and the idea is that you have an inverse mask. In other words, it's the opposite of a typical subnet mask. The only thing that is different than the way this is applied in OSPF is that in access control lists, the wildcard mask by itself is really not that important. It's the access list IP address that's placed in front of the wildcard mask. So for instance, let me put in here, if I had access list 1 permit 192.168.12.0, and I put in 000.255. What this is saying is that this ACE, this access control entry, will only affect packets coming in that have a 192 in the first octet, a 168 in the second, and a 12 in the third octet, because those are the significant bits. So the wildcard mask is important, but it's really the IP address in front of the wildcard mask that determines what the ACE is going to act upon. If I change this, change this to 13, you notice the wildcard mask never changed. But now I'm doing something very different. Now I'm only permitting all of the packets from 192.168.13. So the wildcard mask here is telling you what needs to be matching, and just like OSPF for wildcard mask, a 0 is significant and 1 is insignificant. So this would permit anything that had an IP address of 13.0 through 13.255. Granted, I know 0 can't be applied, but 13.1 to 13.255 would be allowed. That is a key point, because without the preceding IP address, the wildcard mask in an ACL is pretty much useless. Here we see this means match all octets. So if I did this, okay, if I did that particular wildcard mask, that would be, I did this, that would be a mistake, because that would say match only permitting 192.168.13.0, the actual 13.0 address. Or I could do this, maybe I only want the host 13.10 to be permitted. That would be match every single bit. And so this particular access control entry in access list 1, which you will learn shortly, is a standard ACL, would only match the host 192.168.13.10. So when we're thinking about access control list wildcard mask, always remember it's the preceding IP address as compared to the wildcard mask that determines what will be permitted or denied. It's not just the wildcard mask on its own. Here we see here this matches the first 3 octets and then match the first 2 leftmost bits, ignore the last 6 bits. So this would be if it was a 2x5, 2x5, 2x5.192 subnet mask. Here we have matching the first 3 octets plus the first 4 bits. Here we have matching the first 3 octets and then ignore the 6 most left bits. And this says match the first 3 octets and ignore the last octet. One of the things you get a lot of times is people say block all of the IP addresses on a particular subnet. This is one way you could do that, or a particular network. This is a class C. And then these would be on particular subnets of networks. All right. So we can have a wildcard mask to match a host. Here it is, quad zeros. We can have it to match a standard subnet. Here's a network /24 here. So it's, they say a subnet, but this is technically just a class C or IPv4 subnet / class C network. Here we have it 000.255, and then here we have it matching the range of subnets from 16 to 31. And so we actually have this saying permit, and it would permit any network from 16 to 31, and then also 1 to 255, so all the way through 0 to 255 actually in the 4th octet. So wildcard masks, typically you do even on ACLs, just take and subtract 255, 255, 255, 255 from the standard network mask or subnet mask to get your wildcard mask for ACLs. But you need to be careful because it's not always that way. Here's an example, obviously, starting value, subtract your access control list of /24, and that gives you your wildcard mask. Here you have an example of a 28, and you get this wildcard mask. And then here we have a /23, and there's your mask for a /23. And then this is a /1620 mask, I do believe here. So you can just subtract 255 to the wildcard mask, or excuse me, subnet mask from 255, 255, 255, and that will give you your resulting wildcard mask. Sometimes, however, though, it is possible to use what we call our keywords. So for instance, instead of putting this example here and putting 192.168.13.10 quad 0, I can just put in the keyword host, and that says match all of the the following IP addresses, octets. So this is the same as putting quad 0 at the end. We also can have any, which is replaces 255, 255, 255, 255. So for instance, here we have an access list permit 192.168. This is kind of a weird. This is permitting, well, it's two different access control lists. That's why it makes sense. But you're going to permit 192.168.10.10 single host, and then access list 11 permits everyone. Okay, hopefully you've got a deny statement above that somewhere, but and then those could be rewritten as permit host and permit any. So any can replace quad 0 and quad 255. Saves you a lot of time when you're doing extended ACLs, especially. So again, you can have one ACL per protocol, per port, per direction. So on a single port, you can have one inbound IPv4, one outbound IPv4, one inbound IPv6, one outbound IPv6. And then, of course, we're only showing IPv4 and IPv6 ACLs, but there are ACLs for MAC addresses. There are ACLs for all different kinds of protocols. So just be aware, that's all we show you in the CCNA, but there are other ones. Still, I would say typically we only use the IPv4 and IPv6. So a single port could have up to 4 ACLs on it. It'd be 2 for the IPv4 and 2 for IPv6, but it's always one protocol per port one ACL per protocol, per port, per direction. And always remember that it's from the standpoint of someone sitting in the router itself. So outbound was leaving the router, and inbound is coming into the router. All right. So again, we have here, this would be if you had ACLs on all the ports going both ways, you get up with 4 on the left side and 4 on the right side. But it's outbound is always from the person sitting in the router going out that interface, and inbound is always coming towards the person sitting in that router. Now, what are some of the best practices for ACLs? Well, they need to be based upon your security policy. That's a big thing. They need to be written in a logical order. And we'll talk about that more even as we get into Module 5, where we're going to look at how to configure ACLs. Best practice is to create them in a text editor or in Notepad++, save them, keep them there, test them, use remarks. Also, I would say make sure you test them in a development network, because once you apply an ACL, if it blocks your access to a router, you're done. Once you apply it to a port, you can lose access. There is a command called reload in, and you can actually, if you're working on a remote device, put in an access control list, you can put in the command reload in three minutes. Put a command in. If it works, you're fine. Then cancel the reload. Just realize anytime you're reloading a running router, a working router, you're going to cause disruption in data being delivered for your users. But that's why you try your best to always develop them in a test network. That will help you from locking yourself out and causing other unexpected errors. We have 2 basic types that we deal with in the CCNA, and they are standard ACLs. And standard ACLs, if they're numbered, now by the way, standard and extended can be both numbered and named. But for numbered standard ACLs, the numbers are 1 to 99. So this is a standard numbered ACL. And you can also use 1300 to 1999 if you need to. And they filter based only on source IP address. So this would be the source IP address of the host I'm wanting to permit. They should be placed as close to the destination as possible. Now, here's the thing that a lot of people do. This is a general rule, and it's a book rule and an exam rule. So if you get a question on the exam, put it as close to the destination as possible. Real world, you may want to look at your traffic and make a decision about whether or not you do put it as close as possible because of the logic of the flow of data in your network. Extended ACLs, and by the way, I call standard ACLs the shotgun approach, just kind of get in the ballpark because you're just using the source IP address as your filter. Extended ACLs, if they're numbered, are numbered from 1 to 199 or 2000 to 2699. They filter based on source IP, destination IP, source port, destination port, and can even do protocol. So you can filter based upon UDP, TCP, even destination ports. So all of those are available. Typically with extended ACLs, you put them as close to the source as possible. So when we look in our curriculum here and take a peek at it, you can see that here's a standard ACL that says permit 192.168.10.0. So this is permitting the network 10.0/24. This is an extended ACL, which is access list 100 permit TCP, so your protocol, from this network 192.168.10.0/24 to any other network or any other IP address. By the way, remember the any is simply replacing quad 0, quad 255 equal www. So this would allow web traffic from your /24 network 10.0 to any other network. We'll talk about full configuration in Module 5, but that's important there. We also, instead of using numbered, can use named. So we can do IP access list standard and give it a name. And then we will have, this would be, by the way, if it was standard, it'd be config-std-NACL, which stands for named access control list. This is IP access list extended FTP filter. So it's an extended NACL permitting TCP from the /24 network to any other, 10.0/24 to any other network or any other IP address equal FTP and FTP data, so 20 and 21. Named access lists are nice because they're a little easier to work with. They make a little more sense, but sometimes you don't need them. For instance, if you're using a standard ACL to control traffic to your B2Y lines, just use a standard ACL instead of a named. All right. Now, where to place ACLs? Extended ACLs should be placed as close to the source as possible. So if you're trying to permit traffic or deny traffic from 10.0, you could put it on the inbound on gig 000 if you're using an extended. If you're using a standard and you're trying to control traffic from the 10 network, you're going to need to either put it all the way over here, all right, on the S001, or really if it was applying to one of these two networks here, so in other words, you wanted the 10 network to have access to the 30 network, but not to the 31 network, you could apply the standard access list here to block traffic from the 10 network. Now, the problem with that is, quite honestly, well, there's a bunch of problems with standard ACLs, but one of the reasons you can't put it, for instance, you look here, the 31 network and the 30 network. If I was to put an access control list, a standard list, so let's look at the standard list here, and let's deny, okay, host. Pull this down a little bit. This is going to be 10. So let's do deny host 1010, access list 1 permit any. Okay, so that remember is just replacing any, simply replaces quad 0 and quad 255. So it just saves your typing. All right, so if I had that access list right there and I applied that ACL here, okay, on inbound, so that's standard access list, I did it inbound. I am now blocking host 1010 from any other network in my entire organization. Maybe what I was really trying to do is just blocking that host from being able to get to this server 3112. If I had made it an outbound, this extended ACL, so I created it on R3 and placed it as an outbound on gig 001, then this standard ACL would have denied host 1010 from getting out on the 31 network, okay? But here's the problem with the standard ACL, it would have blocked it from anything on the 31 network, all right? And would have permitted all other hosts to be able to get to the hosts on the 31 network. So access control lists, especially standards, have some issues when you're thinking about how to create them and apply them. Typically in real world scenarios, we're going to be using extended ACLs because we want more control of how we use them. Okay. So again, here we have standard ACLs as close to the destination as possible. So, and the problem here is if you put it in the inbound on S001, it would block anything, all traffic going to 30.0 and 31.0. So if you place it here, that's incorrect. But if you place it as an outbound here, then you would have correct placement. In other words, I'm blocking the 10 network from going to the 30 network, but I'm still allowing to go to the 31 network. With extended ACLs, you can put it on the, as close to the destination, as close to the source as possible. So I could block FTP and telnet traffic from the 11 network to the 30 network. And really you would want to do that going inbound on gig 001, because there's no reason, if you're going to drop traffic, for instance, I'm going to block FTP and telnet, so I'm going to drop this traffic. If you put it as an outbound on 0010, that traffic has to go through the routing plane. It has to get switched from the ingress to the egress interface. Then it's dropped on the way out, which is insane. So just place it on the inbound interface, and then that way the ACL will drop it before it ever goes across the switch back, or excuse me, the router backplane. And folks, that is a very short little module on ACL concepts. I hope this has been helpful, and our next move will be to look at actual ACL configuration.